Welcome to Module 6. Nearly everything we've designed so far will run in someone else's data center. So this module translates privacy engineering into the cloud's native controls with AWS and Azure as our reference platforms. I've implemented these controls on both, and the concept map across to GCP and any other cloud service provider out there. We'll cover the shared responsibility model as it applies to privacy, encryption and key management, data residency, identity and access, the logging pitfalls that catch almost everything, shadow data, and the sub-processor layer underneath your vendors. Start from the shared responsibility model, the privacy edition, and notice it's just module 2's controller processor relationship wearing the cloud clothes. The provider is your processor. It secures the physical layer and the service infrastructure, acts on your instruction under Article 28 data processing terms, publishes sub-processors list, and also publishes audit reports. And also, most importantly, it offers the controls. Now, you are the controller. What data goes in, why, on what basis, configuring these controls, retention, deletion, and minimization are entirely yours. The line worth remembering is that the cloud gives you world-class privacy controls. Switch to whatever default happens to be. And enforcement history is unambiguous. Regulators fine tenants for misconfigurations, not the cloud service provider. Now, here's the map for the rest of this module. We'll focus on 6 control areas. Encryption and key management. This is where the real question is never is it encrypted, but who can decrypt? Residency and regions. This is where data lives, where it replicates, where certain services quietly send data to. Identity and access. Least privilege applies specifically to personal data. Logging and telemetry. I call it unminimized shadow copy of your product, and it deserves its own slide. Storage and shadow data. The bucket, snapshots, and orphan disks nobody remembers. And lastly, the sub-processor layer. The vendor under your vendors. One slide each with AWS and Azure names throughout this session. Starting with encryption. Everything in the cloud can be encrypted with a checkbox, which is why encryption itself is table stakes and key management is the actual control. Now let's look at the concept of default at rest and encryption. This can be applied to S3 bucket, EBS, RDS on AWS, or you have storage managed disk, or for example SQL servers in Azure. This is helpful to protect against stolen hardware, but of course not against your own overpermission services reading everything. The next you have customer managed keys in key management system or key vault put rotation. This gives you the policy and revocation, and actually put it in your own hands, and the key policy becomes the true answer to who can read this data and who of course cannot read this data. The next you have per tenant or per user keys. This unlock the crypto erasure pattern which we discussed in module 5. Generally, when you destroy, the concept here is that once you destroy one key, the user's data, including backups, all goes dark. And lastly, you have the client field or field level encryption. And here the provider generally never sees the plain text as the data is encrypted on the client side or on a field level basis. This is one of the strongest ways for encrypting and protecting users' data. It is reserved for special category fields because of its operational cost. Because of course, encrypting at the field level is cost consuming. Now, match the wrong to the classification tab from module 3 if you remember. Default for T1, which are the default, and then CMKs for T2, per user and per field level, where T3 lives. If you remember, T3 was special category data, and T2 was ordinary personal data, ordinary non-sensitive data, and T1 was general data. Residency operationalizes Module 2 transfer rules. Now, on the left column, this is the pinning that holds. Enforce at deploy time with organizational level guardrails. Service control policies in AWS organizations. Allowed locations in Azure policies, for example. So generally, the idea here is that a developer can't create the resources in the wrong region even by accident. Also check replication default, because cross-region backup and disaster recovery cheerfully copy personal data across borders. So it's important that you also have a look at the replication default that you have set up. Then also pin, general advice there is also to pin the whole chain, the compute, the storage, the queues, your CDN logs. So you're not just looking at the database or a storage, you're looking at the whole data lifecycle chain. And if you remember the lesson from module 2, an architecture that can repin regions is the durable asset. Now on the right column, this is where pinning quietly leaks. Some identity, DNS, CDN, and AI services are, for example, global by design, and would by design process data outside your choosing region. Also, we have cases of where support and remote access is performed on a specific on a data. This is also a form of data transfer, even though the data still remains in the same location where it was. Marketplace SaaS bring its own geography, and metadata streams often have provider side homes. Now, the discipline here is that you should always verify residency. You should always verify where your data is going, services by services, in the documentation. I mean, not just focusing on your database or focusing on storage. Next, we will talk about least privilege and how that is applied to personal data. Identity and access tune for personal data. There are 5 practices in general that I'm going to call out. The first one, which is purpose-shaped rules. These are when we shape when rules mirror processing purposes rather than organizational charts. This is helpful to support, like read profile, analytics read, pseudonymous, never giving a general analyst role that reads everything. And if you remember, this also this also ties to purpose limitation that we discussed in module 2. So generally giving access purely based on purpose, what is needed for that specific purpose. Then you have tagged based access control. Here we tag resources by classification, by classification tier. If you remember in module 2, also in module 3 we talked about classification tier. Then we write policies that grant by tag. For example, ABAC conditions in AWS, RBAC plus policy on Azure. So classification does daily work instead of decorating a spreadsheet. So basically here we give access to the data based on the tab. Next, you have humans out of production data. Engineers debug in this case, engineers debug with synthetic or max data rather than using production data. One of the things I've seen so far in the industry is that during UAT testing or even engineering the bugs, they tend to use production data, which is a serious breach and a serious issue. So the concept of getting humans out of production is that debugging should be done with synthetic or masked data by default. Next, you have break class with receipt. This is where you have emergency access exit. This is where emergency access exists, but it is time boxed, approved, alarmed, and reviewed after every use. And also a quarterly recertification of who holds tier 2, tier 3, tier 1 access, and so on. Also, in this case, you also ensure that dormant grants are expiring automatically. Final point, the access log themselves. For example, you have like CloudTrail, Azure activity logs. These are accountable evidence, so it's important to retain them and also review them, as they could provide you a lot of insight into who has who has access to your systems and who doesn't. If one module saves you from a finding, it's this one. Your logs are a second database, unminimized, unmapped, and mostly retained forever by default. Now, here are some of the common traps. You have request logging. So a request log that captures full URL, including the email address, and this kind of lives in a query strings, plus headers and bodies, and sends and feeds these data straight into CloudWatch or any application that you're using for insights. You also have error dumps that serializes entire user object at exactly the moment nobody is being careful. Then you have access and load balancers that logs where IPs plus path reconstruct behavioral history. It is mostly enabled once and never revisited. And lastly, default retention. Here, the data retention for logs never expire, and log groups are just there quietly violating every retention promise that you have in your privacy notice. Now, the fix is mostly in configurations, right? You need to make sure you have structured logging with an explicit field allow list. You need to use hashing and truncation and make sure it is applied at the log shapper layer, so it's centralized rather than per developer. Retention should also be set on every log group and workspace, and logs inside the scope of your deletion pipeline from module 5. So you need to ensure that our logs are inside our deletion scope and deletion pipeline. Now, in my audit, log stores are the single most common places deleted users are still alive. Now, let's talk about shadow data, the copies nobody remembers. So how does shadow data accumulate? It comes from snapshot and machine images, often disks from deleted instances, ad hoc export packed in personal bucket, test environment seeded from production, and for example, temporary CSV where birthdays was being celebrated. Now, how do you find shadow data? This is what data discovery services are mainly built for. In AWS, you have Macie. In Azure, you have Purview. You also have other tools that do data discovery like OneTrust, security, AI, and lots of other tools out there in the market. These tools are very good at scanning storage for personal data patterns, identifying that data, and even to some extent helping you in classifying those data, which you can then act upon. So combining this with cloud inventories, and also making sure you have quarterly rescan cadence, as we discussed in module 3, to make sure that you always have insight into what hidden data you have. With this, discovery becomes a routine instead of something that is just done once and forgotten. How do you prevent having shadow data in the first place? Now, some of the measures you can take is blocking public bucket at the organizational level, default deny snapshot sharing, using mass data for test environment, which also serves the IAM goal of keeping humans out of raw production data, and also putting expiry tags on every export. Now, the stakes stack up because every unmapped copy is simultaneously a data gap, a data mark gap, and then it will be a deletion miss and a breach headline. Beneath every vendor sits a stack of sub-processors, and the controller, which is you, should answer for the whole tray. You can do this with 4 moves. First of all, inventory the chain. Your cloud is sub-processor, your marketplace SaaS, and theirs is always deeper than the architectural diagram admits. Next, contract the chain. Article 28 terms must flow down, and sub-processor changes should come with notice and objection right. Actually, subscribe to those change feeds. That's what they are actually there for. Then next, constrain the chain. You can do this technically. For example, using private connectivity instead of public egress, scope tokens instead of admin keys, and vendor access logs with the same rigor as human access. And lastly, rehearse the exit. Look at things like export, and ensure you have things like export format, deletion, arrestation, and offboarding tested before you actually decide to leave that vendor. This is something that commonly happens, changing of vendor or leaving a vendor and moving to the next. And the worst time you can discover that a vendor can't delete your data is actually when you're moving, when you're leaving them. Um, this is this also refers back to module 3, where we talked about vendor mapping. Now let's go back to our application Stridewell, and let's see if we can harden the cloud layer. Starting from the keys, in Stridewell you need to have health and cycle data move per user customer managed keys, which means the crypto erasure pattern finally covers those 7 years backups that was flagged in exercise 1. Then for regions, we need to have an EU only allow list enforced by organizational policies, with disaster recovery repointed to a second EU region instead of quietly crossing to the Atlantic or to different regions. And then for access, the analytics role is restricted to pseudonymous tables via their tags, and production debugging happens only on masked replica of that data. Now, for logs, a field allow list at the shipper. Also, we should use truncated IPs, and also have a 90-day retention on every groups, and logs joining the deletion pipeline. And then for shadow data and vendors, we should have monthly storage scans, and the add SDK egress moved behind a private link with a scoped token. So this is same app for module 4, the cloud layer now pulling its weight. So it's important to keep your notes. In our capstone project, we are going to ask you to document exactly this kind of hardening which we've just gone through for Stridewell. Now we've come to an end of this module. Four important takeaways that I would like you to carry forward. 1. The cloud offers superb privacy controls set to whatever the default happens to be. Configuring them is your job, is the controller's job, and enforcement lands on the tenant. Number 2, key management, not encryption, is the real control, because by default all cloud platforms would offer you encryption just by click of a button. Later from platform defaults up to per user keys as the classification tier rises. Number 3, logs are a second unminimized database. So use allow list fields at the shipper, set retention on everything, bring log into your deletion scope. Number 4, residency, shadow data, and sub-processors all yield to the same discipline. Verify service by service, scan on a schedule, contract and constrain the chain, like we discussed in the previous slide. Now, in our next module, we are going to discuss about privacy enhancing technologies, which I guess is the module that most of the listeners have been waiting for. We are going to talk about differential privacy, federated learning, and also about the honest conversation about when they are actually worth their cost. See you in the next module.